Hello friends, this video on is matter around us pure part 16 is brought to you by examfear.com. No more fear from exam. Let's take some questions here. Which separation technique will you apply for the separation of the following particles? Sodium chloride and its solution in water. So I have here NaCl and water. Now we see that sodium chloride in water, NaCl is non-volatile, but water at 100 degrees Celsius is volatile at 100 degrees. So what we can do, we can just do evaporation here. So if we do evaporation at 100 degrees Celsius, water will convert into gas and the sodium particles NaCl will actually be here itself. It will be somewhere here. The next is ammonium chloride from the mixture containing sodium chloride and ammonium chloride. Sodium chloride is non-sublimate. Ammonium chloride is sublimate, be something we know. Since one is sublimate, one is non-sublimate, what we can do is, this is the order of ammonium chloride and sodium chloride. Since one is sublimate, one is non-sublimate, we can use sublimation process here. So we can use sublimation process here. Small pieces of metal in the engine of the car. So if you see an engine oil of the car that is used, it will have small pieces of metals. For example, this is an engine oil and this is small piece of metal. Want to separate them. Since these small pieces are pretty big, you can actually use a filtration process. You can use some sieve or filter paper to actually filter out the small metal pieces. So we can say it is a filtration because these particles are big enough to be seen by naked eyes as well, and it will not pass through filter paper. So we can typically use filter paper to separate this particle. Different pigments from the extract of the flower petal. So we have seen these flower petals have different pigments, and to separate them we use chromatography, because all these pigment particles, for example, you have black color dye also, it will have red, blue, pink, yellow, all these colors, and these colors have same boiling point, melting point. So actually you can't separate by evaporation process and other process. So but they have different stickiness tendency to some solvent. So typically we use chromatography in this case. Butter from curd. We know that the butter is lighter than curd. So what we can do is, if you want to take out from this curd, if you want to take out the butter, so what you can do is you can actually use centrifugation. In centrifugation also, the lighter particle will come up and you will get butter from curd. Okay, that is one. The next is we have to find out more. Oil from water we have to separate. So there's oil and water, and these we see they don't mix, and oil is lighter. So if you keep this suspended for some time, what will happen is the oil will come up and the water will settle down because the water is heavier. So we can actually use a separating funnel here. So we have shown you this. You can watch some of the previous videos in the same chapter where we've explained this. The next is tea leaves from the tea. Let's suppose you're preparing tea. This is a tea and it will have some tea leaves when you prepare, and you have to separate. Now since tea leaves are big in size, you can actually use sieve, that is a filtration process, to separate tea leaves from the tea. The next is iron pins from the sand. Sand has some iron pins. So now if you see, what you can do is, one thing you can do is you can actually use the magnetic property. This iron is magnetic, right? It is attracted toward magnets. The sand is non-magnetic. So you can use that as well. Or if the iron particles are big in size and sand is small, you can use filtration also, if that is the case. But if the iron particles are very small, almost same size as sand particles, then you can't use that, right? Because in the filter, whatever filter you use, both sand and iron particles will pass through. So you have to use magnetic property, okay, magnetic separation. But if there's a difference in the size, you can actually use filtration. But here I will go for magnetic property because that solves both the purpose. In all the scenarios, this will work. Wheat grain from the husk. This is husk. This is how it is cultivated. From this, you have to take out wheat grains. So what we do is we first hit it hard. You hit it hard, then both get separated. And this, the outer layer of the husk is light. It is very light. It's a very thin film. It's very light. But wheat is heavy. So what we can do is, since one is heavy, one is light, we can use winnowing. Winnowing is you keep this and try to put it down, and some wind blows, and with that wind, this is the light particles, it flows in the air, and the heavier particles settle down. It's like this. You have this kind of structure, and you put a fan here. Let's suppose fan will blow air. So in this you have mixture of the whole grain plus husk here. Now if it comes down, since there is a fan here and the wind blows, the husk will go here and the grain will settle down. So what will happen after this is all this grain will come settle down here, and the husk will flow, and all the husk will be collected somewhere here because of the fan or wind, heavy wind actually, because this is particle is lighter, husk is lighter, it will float in air, and the grain is heavier, it will not float in air, it will settle down. Okay, you can try this kind of experiment in home actually, where you take one light particle and heavy particle and you try to throw in front of a fan. You will see that the lighter particle will go and settle down somewhere far, but the heavier particle will fall down immediately. Okay, you can try with maybe a small piece of paper, and you can take some dal, heavy dal, or you can take wheat itself. You take some wheat and mix it with some small piece of paper if you don't get the husk, and then you have the mixture, and then take it in front of some fan and try to throw it or try to put it down, and then from the wind speed this paper particle will come and settle down or flow in the air, and the wheat will actually be collected here. Okay, fine mud particles suspended in this air. So fine mud particle which is suspended in this water, we can actually use sedimentation process. You can leave it for some time, all this will settle down, and whatever you have, you can use the filtration process also if you want to really filter it out better. Or you can use centrifugation for immediate sedimentation as well, or you can leave it for some time, it will come down. So many steps you can use actually. You can use sedimentation, you can use filtration, you can use centrifugation. You can use all three combined actually in this. Okay. How will you confirm that the colorless liquid given to you is pure liquid? For example, a stranger comes to you and he gives you a glass of liquid, and he asks you, tell me if it is water. See, a colorless liquid can be acetone, it can be alcohol, it can be anything, it need not be water. How will you confirm? See, what you can do is, for this, you can actually boil this. If you boil the colorless liquid, and if it is pure water, everything will start boiling at exactly at 100 degrees Celsius. So we know one property that pure water boiling point is 100 degrees Celsius. You keep a thermometer as well here, and you just boil it at the rate 100 degrees Celsius only. So if it boils at 100 degrees Celsius, there is a 90% chance it is water. To double check, what you can do is you can actually let the whole water boil. You can take a small sample of water and you can let the whole water boil. So if everything boils up, there is nothing left, there is no residue left, that means it was a pure water. If not, you will see some salt or something, some sugar, that means it was not a pure water, it had some impurities as well. So with that you can actually find. First thing is knowing the fact that the boiling point of pure water is 100 degrees Celsius, you confirm it is water, and double check, you boil the whole sample of water and make sure nothing is left in the vessel. If nothing is left, that means it is a pure water. Which of the following materials fall in the category of pure substance? Is ice a pure substance? See, if it is made from pure water, yes, ice is pure substance. Is milk pure substance? No, milk is a colloid. We know milk is nothing but water and fat. Iron. Yes, iron is a pure substance, because iron is what? See, ice is what? H2O. H2O is compound. Iron is what? Fe. Fe is metal. Metal is element. Right? So ice is yes, milk is no, iron is yes. Hydrochloric acid, HCl. So HCl is a compound, hydrogen and chlorine. Yes, it is a pure substance. Calcium oxide, CaO. It is again a compound. Compound is nothing but a pure substance. Yes, it is. Mercury thermometer. Yes, it is a pure substance. It is an element. Brick. No. Brick has so many substances in it. It has soil. Soil itself is not a pure substance, right? So brick is not a pure substance. Wood. No. Wood is also not a pure substance. Wood also has so many things. Cellulose, nitrogen, so many things it has. So wood is not a pure substance. Air. Now air, if you know, air has oxygen, has nitrogen, has argon, so many other gas. So air is also not a pure substance. Okay. Identify the solution among the following mixtures. All these are mixtures. All these are mixtures. I have to find which one of these is solution. Right. So for solution, what we know is it will be stable. Correct. Particle size is very small. Particle size is very small, and no Tyndall effect. Okay, so let's see. Soil. Soil, if you see, it has so many things. It has so many minerals, right? It has dead bodies of the plants also. So it is not a solution at all. It has so many particles, so many big particles. It is a big, it is a, and in fact, solution has to be homogeneous, right? So this is a heterogeneous. So soil is not a solution. Seawater. Seawater has NaCl, correct? Seawater has water, plus seawater has some minerals, but it is a homogeneous mixture, right? And if you take seawater, you will see it will not show Tyndall effect as well. Since it is homogeneous, I can say yes, seawater is a solution. Air. Air also, if you see, air actually is a colloidal solution, right? Air is a colloidal. We have seen that, and that's why if some light comes from in a dark room from some window, you will see that Tyndall effect, right? So air is also a colloidal solution. So we talk about solution here, I'm talking about both colloidal solution and a normal solution. Coal. Coal, if you see, coal has so many particles, right? Coal has carbon, so many impurities, and they are all heterogeneous. If you take some coal from here, some coal from here, it will have different composition. So coal is not a solution. Soda water, yes. Soda water, if you see, it has soda and water, and it is, and it has carbon dioxide also in this, and it is totally mixed properly. It is a homogeneous solution, so it is yes a solution. So Tyndall effect is closed because we are talking about both colloidal and solution. If you talk only about solution, then you can remove this air. Which of the following will show Tyndall effect? Tyndall effect, you put a laser light and you see a dispersion of light, scattering of light. So if you see a scattering of light, then it is a Tyndall effect. Salt solution, we know it is a pure solution, so it will not show Tyndall effect. Correct? Only colloids show Tyndall effect. Milk, yes, we know that milk is a colloid, so it will show Tyndall effect. Copper sulfate solution. Copper sulfate also is not colloids, actually it is a normal solution, so it will also not show Tyndall effect. We have seen this. Starch solution is also actually not a colloid, so only milk will show the Tyndall effect. Classify the following into elements, compounds, and mixture. Sodium. Sodium is in the periodic table, so it is a element. Soil is a mixture because it has so many things. Sugar solution has sugar and water, so it is again a mixture, right? Silver is an element, it is in periodic table. Calcium carbonate is again an element, it is a compound. Actually, it's not an element, it's compound. Tin is an element because it is in the periodic table. Silicon is in periodic table, it is an element. Coal. So when you talk about coal is a mixture. We just saw, right? It has so many impurities and all. Air. When you talk about air has oxygen, nitrogen, carbon dioxide. It is actually colloidal solution, so I can say it's a mixture. Soap has so many things, so many compounds mixed together, it's a mixture. Methane is CH4. CH4 is again compound because it has elements, right? It is compound. Carbon dioxide is again compound because it's CO2. Blood, if you see, is colloidal. We have told you this, blood is colloidal. If you take some drop of blood in the water and mix in water, you will see the Tyndall effect. Blood is a colloidal solution. So with this, we can classify these elements into things into elements, compounds, and mixture. Okay. Next is which of the following are chemical change? See, growth of a plant, is this a chemical change? I don't think so. Plant is still the plant. There is no chemical reaction there, right? So it's all same. If it's growing, is a physical change. Rusting of iron, yes, because iron becomes Fe2O3. This is rust. You study in higher classes. This is iron, pure iron. So from element you are making compound. This is sure short of chemical change. Mixing of iron filings and sand? No. If you mix iron filings and sand, there is no chemical reaction. Just a physical reaction, physical change. Cooking of food? Yeah, I can see that the food gets cooked. There's some reaction happening in the cook because it happened at the high temperature. So cooking of food will be a chemical reaction. Digestion of food? Yes. Because we eat something, we eat carbohydrates, everything is broken into energy. So that is yes, a chemical reaction. Freezing of water? No. Water when you freeze, it is just a physical property change, right? This is still H2O, this is also H2O. There is no chemical change, just a physical change. Burning of candle? Yes, because the wax is converted into chemical energy. So this is a chemical change. This is also physical change as well, but this is a chemical change also. So this is a chemical change, yes. So these are the chemical change. The one in the correct is chemical change. There is rusting of iron, cooking of food, digestion of food, and burning of candle. They are the chemical changes.
Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.